So here we have two tables, right? We have created two tables, which is customers as well as customer orders, right? We have inserted some sample rows. If you could see, this is our these are our sample tables, right? This is our customer orders table where we have some details of orders, order ID, customer ID, order date, order amount, and status. This is our customers table where we have customer ID, first name, last name, email, status, and when we have created it. Right. These are a few columns related to these two tables. Let us understand few best practices. Okay. So first thing is you could understand. First, we need to understand what is our data and what are the requirements. Right. So before starting, writing any query, we must ensure that we have clear understanding of the data. What is the structure of the tables, right? What is the relationship between the tables? What is the desired outcome that we want so that we can craft the query more efficiently, right? So this is the first thing which you have to do before discussing about anything, right? In order to understand the data model or anything, you need to like you can use this feature of database diagrams, right? You can right click on that. If you have never installed this support, you can just click on this install diagram support. You can click yes, and you can just right click on new database diagram. Right here, we'll take these two tables and let us click on add, right, and close this. So you can see this. These two tables are automatically, related because we have created that foreign key and the primary key related to these two tables, right? If you want to delete the relationship, you can see that. Otherwise, you can click on properties and you can see the property over here, right? What is the kind of relationship? And if you want more things to explore, you can just try to explore here, right? I can close this. And what we shall do is we can understand the model over here. We have only two tables. Now we'll take some examples. We can save this. Here I'll just undo it. Okay, so since we have understood the two tables and we can explore the model as well, how to add those diagrams you have seen, let us understand few good practices. Okay, so the next good thing is you could understand use a descriptive table and column names. Suppose if there is any customer table with these columns like CID, F name, last name, L name, like this kind of thing with like these kind of names without proper understanding, you should try to consider changing the names. Okay, you can keep it with proper names like customer ID, first name and last name, instead of writing those names, right? If I execute, you can see that we have proper output with this with respect to this table, right? Next thing is, right, try to keep the queries simple and readable. Okay, so use proper indentation. Like this, you can write each and every command in new lines and write it neat and clean without any inappropriate indentations, right? So reading in like writing the queries in multiple lines, it gives better readability, right? And try to avoid complex and nested queries. If at all you can bring in a simple solution for it, right? This is one good practice. Once we move ahead, in this way you can write the query in proper with proper indentation and appropriate words, right? Next thing is you can use aliases. What is aliases? Like a names which are more shorter and easier to read. Here you can see that in from clause for customers table I have given the name C, right? So we can use that C dot customer ID, C dot first name, C dot last name, so that we can call them by using the short name, right? The respective columns. Even if we don't use that for single table, it will work. When you use multiple joins, those repetition of names would create a little chaos between the tables. So it is good practice to use alias names, right? Which are like a nicknames for people, right? These are alias names for tables, right? Next thing is we can optimize select statements. For example, if there are multiple columns in the customers table, right, here we have multiple columns, right? But as a user, suppose that we want only these two columns. Okay, as a user, maybe the user do not require any other columns. So what we can do is we can fetch only the respective columns. Do not fetch unnecessary columns which are not required. So that could optimize your queries, right? That is one thing. and also use where clauses to wherever you can filter the data and reduce the data set size early, right? If at all you don't require all the customers, if you want to require, if you require only those customers whose status is active, you can try to write a where clause like this, right? You can enter, write where clause where status is equal to 1. If you execute, okay, you need to remove this semicolon and then you can execute, right? You can get this. These are the customers who, who is active in status, right? Next, you could say best practice is using indexes. Okay, so what are indexes? You could understand. Suppose there is a book. Okay, we have a book. We have a table of contents, right? Say table of contents with page numbers and chapters, right? We'll have multiple chapters like this, and we have certain page numbers. So in order to reach out to the particular chapter, that particular page number will help us to quickly navigate to that particular chapter, right? So in that way, for a table, we can index it so that our query runs faster. Okay, it can be especially faster when we frequently use with these different clauses where join order by clauses. For example, we'll see different examples. If there are, okay, some columns, we use indexes on only on those columns, okay, which has either unique rows, or we use indexes only on those columns which is frequently, asked, right? Which is frequently queried. For example, status column could be a frequently queried column, right? So what we can do is we can create an index. It is index name on which table, customers table, which column, status column. I can create that. Now if we see the customers table, I can open the customers table here, and if I just try to refresh the index, you can see we have this IDX status. You could say index being created. So whenever we call this particular right query, instead of table scan, we'll be able to see that something called as clustered index scan. So here you can see, usually without creating the index, if you run, you'll be able to see the table scan. For example, if I delete this, right? Now, if I just try to run the query, and if we see the estimated plan, okay, so it is again acted, right? Okay, we have this particular primary key, so it is already having clustered index. So by default, if you have primary key, it'll be, there will be a unique clustered index being created. Okay, this will by default help us to query quickly, but it depends on the column which is being created. This is created based upon the customer ID. But if at all you want to make it faster and you need to create index on status column, you can create this kind of index. It will still do that index scan, right? Clustered index scan. You could see that, it will create the clustered index scan. If you don't, if you don't have that primary key, or if you don't have that clustered index scan, or if you don't create an index, what happens is in a table, each and every row will be evaluated one at a time, right? So it will iterate row wise, and it will consume lot of, memory processing, and it will consume time, or you could say it will process little slower compared to the table which has index, right? That kind of scan which iterates row wise, it is called as table scan, right? And this one which we have index, we call it as clustered index scan. Okay, why it helps? If there are millions of rows, searching for rows status equal to 1 will be much faster with an index on status, right? Without an index, SQL Server would perform a full table scan. Second thing is when we have joins, okay, so here we have made a simple inner join, right, with customer orders related to the customers table. Here we can understand that we can create indexes on two columns, right? On which column? In customers table, customer ID column. In customer orders table, customer ID column, right? Those are two columns where this particular join will be, you could say, queried fastly, right? I'll create these two indexes. You'll be able to see the respective index over here, right? You can see one IDX customer ID over here, which is being created, and this will be created in other table, which is customer orders table. I can open this. right? I can just right click configure, right, refresh. Here you can see that order customer ID. In this way, it will help you to even do that particular clustered index scan, right? Here you can see there is both non-clustered as well as clustered. Okay. Later on, once you try to understand indexes, you'll be able to understand that, right? Like we'll be diving deeper if at all you are going to join that factory SQL sessions. Otherwise, like you can dive deeper, right? You can understand different types of indexes and you'll understand what it means. You could understand here we have clustered index and non-clustered index together. We'll have that inner join being processed and we'll get that select query, right? Which could be processed faster only when it compares to compared to the joins, which results in full table scan, right? I hope it is understandable. Let us move ahead and understand whether we can index the columns which is present in order by, right? So this is a simple query where we can just use that particular first name last name from customers order by this last name, right? So we have repeated names, we can use distinct also, not a problem. But again, if you need to create an index, you can create on last name just like this, right? Once you create it, you can just see that particular query, right? I can refresh. I can refresh the indexes. You'll be able to see that customer ID. Okay. Like index which is present. Like again, just as the earlier example, how it helps. The database can retrieve the data in sorted order directly from the index, avoiding the table scan, right? Avoiding the overhead of sorting. Instead of sorting it again and again, this index will help to retrieve very quickly from the sorted order. Okay. Similarly, we can create index on multiple columns like this, right? The syntax is same, but you can create multiple, like use multiple columns to filter, or you could say figure out the index, right? For example, we have where condition where we have used that particular two columns in order to select the data. Right? If we execute, we are able to see this, right? And if I just create on both the columns, if I just try to create, refresh it, you can see we have created on the last name also, right? And we can check this particular query. You can see clustered index scan again, right? So this kind of indexes where indexes are created on multiple columns, it is called as composite index. Okay. How it helps? Again, it allows SQL Server to efficiently filter rows based upon both the columns in single pass, like at one time. We can again index on foreign key columns also, right? In order customer orders table, customer ID is our foreign key, just as I have shown you the relationship. So customer orders table, we have customer ID as foreign key, and we can create that particular index on that particular column also, which will which will speed up the join process and quickly match the rows between the orders table as well as customers table. Right, I can just query this, and even here you can see that clustered index scan happening just like earlier, right? And you can just inner join will occur, and then you can get the active output soon. We have something called as covering indexes. What is covering index? Where the index itself contains all the columns needed to satisfy the query. For example, here I do not require a join. It is the same table where I am creating the index. If I execute and just execute this, right, we have only one index, right, being created on these three columns. Okay, so we have all the columns within one table. Such table which consists of all the multiple columns, it will it will help to be called as covering index, and which it avoids the need to access the actual table data, right? When it comes to the index, it queries faster. Okay, in backend, what happens is there will be some memory cache. If you quite repeating, repeat on the queries multiple times, the cache will help you to fetch the data quite easily and quicker. in few cases, depending on the kind of queries that we write, right? Next, where it helps these kind of things, it can retrieve all the required columns directly from the table, avoiding a lookup in the base table, which can improve the performance. There is no join required, there is no subquery, or there is no CT, nothing is required, right? Same table, simple conditions, and we have a proper index. It can fetch us easily, right? It is just like a thing that you could give yourself. If at all there is any object in your pocket, you can take it out and give it easily, right? It is just like that, where you have the columns within a single table. If you are creating a covering index, it can give you the good output with improved performance. Again, I could mention that indexes are not created on all the tables, especially not small tables. Okay, it is always preferred to create indexes where there is huge data, and also on those columns which are frequently queried upon. Otherwise, index also may slow down your operations, especially insert, update, and delete operations. It can slow down a lot, right? So do not use indexes everywhere. You have to cautiously use them. The thing which is helpful for querying faster may also slow your other operations. Slower, like could make them slower also, right? Depending on the kind of usage. So here we can create on particular email column as well, right? Indexing unique columns wherever you find that unique related values. It is good practice to create it so that the user can fetch the data as quickly as possible, right? Okay, so we have already that particular index, I believe. I can just execute it, right? We have some duplicate values. If I check, okay, we have already the key. So it is that we have the primary key. So we do not require it, and you can get the benefit of indexing. But if at all there is no primary key or constraint, you can understand that you require uh, to create the index if possible. Primary key constraint and unique key constraint, if at all you are creating on tables, it is not required to create an index additionally. By default, they will create their own indexes automatically, right? Primary key constraint, when you create, it will create that clustered unique index. Unique key constraint, if you create, it will create that unique non-clustered index. Okay, so you can remember that. Once you practice, you'll be able to understand. I have shown you where to see that, and even the type of index you can just notice here, right? Whether it is non-unique or like whether it is unique depends on the kind of index that you create. If you right click and click on the properties, right, this is our clustered index, right? You can see this is clustered unique index where it is being created. Unique, you can notice over here, right? You can notice over here it is unique and clustered index. Okay, so where it helps in quickly locate that exact row matching the email address without scanning the entire table, right? That is where this particular index help us. So what are the takeaways from this particular indexing? We can use the indexes in where clause, join conditions, right? Order by classes. Composite indexes can be created depending on the multiple columns. We can create indexes on foreign key columns, and we can create covering indexes depending on the available data, with whether it is available in the same table or not, right? Again, just as I mentioned, be mindful of over indexing, as too many indexes can slow down your insert, update, and delete operations, right? It's essential to find a balance between the specific queries to run most frequently, right? This is how we can use that indexing. If we shall move ahead, we can understand we need to use the joins appropriately, right? We need to understand which type of join to be used, and we need to get the desired results. We need to use right type of join, right? Here we have given that orders table example. Just here we need this inner join to find only the matching rows who has ordered, right? So we have these orders and like this order IDs and the respective first name and last names, right? Next thing is we could understand avoid subqueries when possible, right? Subqueries often may give faster output, but again we should avoid it because like joins are more efficient typically, right? For example, we have written a subquery where we can have that order id and first name depending on the customers who has only ordered, right? And also the last name based upon the customers who has ordered, right? And if I try to execute this subquery, we can get this output, right? Second thing is we have the join instead of subquery, right? So the join performs efficiently rather than the subquery. Both gives the same output, right? When you can use something by creating join instead of subquery, better to go for joins rather than the subquery, right? This is one of the good practice. Avoid subqueries whenever possible. Next, if we move ahead, you could understand utilize aggregations and grouping. Okay, so whenever you group, you need to use the group by wisely, right? So here we have a group by command where I can see the customer ID and the number of orders they have made. You can see the count of them, right? So if at all I bring any other column into this particular query, then it might not make sense with respect to these relevant details. Until unless if at all you are like you don't require it, don't use it, right? So always try to keep only the relevant columns in the select clause as well as group by clause. Next, you can comment your code. So this thing, you could say this single double hyphens, right? Or you could say minus sign, double minus sign. You can keep it for commenting single line. Suppose you want to comment multiple lines, what you can use is you can write slash star, right? It will comment it out. Suppose I want to end the particular comment, I can put star slash. Okay, so using this star slash and slash star, this will help you to do that multi-line comment. If you want to remove it, you can remove it. So you can write this particular query like this, right? In order to comment it out, we using interface, you can just select here, or else you can press Control K and Control C. It will comment it multiple times, right? You want to uncomment it, you can press Control U and Control K and Control U. It will uncomment it. Okay, so here we are able to understand how to comment our code. Always before deploying, you need to validate your queries whether you are getting the right result or not. You cannot just think that okay, I'm using the appropriate joins and I'm using the appropriate conditions, then you cannot blindly deploy it, right? You need to validate. You can validate if you are not able comfortable with it. If it is manageable data, you can copy the data, right? You can copy the data like this, copy with headers, put it in Excel, and you can validate if it is manageable tables and if at all it is manageable data. Otherwise you need to understand how to validate in SQL as well, right? Whether the query is performing efficiently or not, you need to test and validate. Next, we have some utility for the transactions. Okay, for example, while performing the operations just like insert, update, delete, we use transactions to roll back, which can help us to roll back the changes if something goes wrong, right? Normally what we can do is, suppose for example, I'll show you the table which is customers table, right? So if I check this table, you can see for the first customer, right, status is 0. So what I'm trying to do is I want to set the status for 1, right? For customer ID 1, I need to put the status 1 for the customers table. So you can see that value is also 0 earlier. Now it will change to 1 directly, right? Without any prompt, right? If I just execute this, it will execute. And if I check the table, you can see that status is 1, right? Now what if I want to, like I do not want to execute and I want to turn back, right? I want to restore the previous value. You won't be able to restore value until unless you update it again or delete it again and create a new row, right? Either you can update it again or you need to delete and create it again. Only these two options are there. Next thing is, suppose if I am trying to begin the transaction, okay, suppose I'll try to begin the transaction. Now a transaction has begun, and suppose for the same customer ID, you are trying to set the status to 0. Okay. Now if I just check the table, you can see the status is set to 0. Okay, now suppose you want to make sure that it is 0 only, then you can commit, right? Whatever the change you have made, you need to if at all you are very sure that okay, that is correct and you want to commit, you can commit, which will by default save your table or data in the table. Okay, suppose that if you want to get back, suppose that you don't like you are not sure and you want to get back to the previous value, you can roll back. What happens if we select this rollback?
It will not work.
It, it will get back to the previous data which is present, which is 1, right? So in this way, once you begin the transaction, whatever the operations that you make, insert, update, delete, right, it can be either rolled back or it can be committed once you are very sure of it. Okay, for example, this transactions can be used in try catch blocks also. For example, by mistake, someone has updated the status column with instead of 1 and 0, they have instead, they have inserted, or you could say updated with text value. Okay, so I'm beginning the transaction like and okay, so instead of writing this complete thing, what we do is, okay, I'm beginning the transaction, right? In the transaction, what happens is there are two, like there is try and catch block. I'll explain you. This is our try block and this is our catch block. So when we check that update statement, if the update statement is correct, it will commit, right? Then the data will be saved. If it is wrong, what happens is it will move on to the catch block. What it does, it will roll back and then print us this particular error, right? For example, if I can see that there is an error here. If I try to select this and execute, you can see 0 rows affected, right? And an error occurred, transaction rolled back. This is the printed error which I have provided. And even it has already rolled back, so nothing is saved, right? Because it is an error, you cannot save that text value into your numerical column, right? Integer column. Even if you want some error message, you can use that error function, which is you can use this error message function, right? And you can just execute. You can see this rollback transaction request has no corresponding begin transaction. Okay, let us begin the transaction. And now let us try this. Now you can see the message. What is the message? Conversion failed when converting the varchar value ABC into data type called bit. In messages, you can see error occurred, transaction rolled back, and one row affected is that particular, you could say, message, right? So in this way, you can use the try catch blocks to handle that particular transactions which are either suitable or not suitable depending on the query, right? Next, we can understand there are something called ACID properties. Okay, so I'll quickly help you understand. You can face this query. ACID properties, A means atomicity. For example, if a transaction has been made between two parties, okay, so either it should become success or it should become fail. Nothing in between. Okay, for example, if you send money to other person, the transaction should be succeeded or it should get failed. It should not happen like you send the money and other person didn't receive and the transaction is under pending for a long time, right? That shouldn't happen. Even in technical glitches, bank is bound to, right, get the refund, right? Bank is bound to refund your money within a certain time. But as with respect to databases, it is completely avoided. There is no even such, like there shouldn't be even such existing possibility. Otherwise it could create an error. For example, there is something called consistency, where database is never left with an inconsistent state. For example, I'll give you one example. Suppose a person A, okay, I'll just show you. Suppose a person called A has balance of 3000 and person B has balance of 4000. Okay, so person A, if he borrows some money from B, of 1,000 rupees, his balance will be 4,000 and B's balance will be 3,000. In both the situations, right? In both the conditions, in both these conditions, you could notice that the total of those both the like total of both the accounts, it remains 7k, right? In both the conditions. So this is something called consistency, where the total aggregated amount, it is same, right? Similarly, with respect to database, the whatever the changes happens, it consistently happen. It does not fail to disturb the database, right? If the insert fails, the customer status will not be updated, right? If the insert statement fails, whatever the condition you give or condition data you give, it will not be updated. Similarly, we have something called isolation. Whenever the transaction is in progress, other users or transactions will not see the partial results. I'll show you one example. Okay, suppose we have begin the transaction, right? And suppose we are trying to update it, right? And what I'll do is I'll just try to go to new query, and suppose I'll try to fetch that same statement from customers. If I try to execute, this particular query will keep on running. Okay, it will keep on running because our transaction has begun, but we didn't end it. So you need to manually stop it. First, try to resolve the transaction, whatever you have made, and then you need to, continue. So here I want to roll back. I can roll back, and then now the transaction has ended. Right. In that way, you could understand what is meant by isolation. When transaction is in progress, other users or transactions will not see partial results. Either it will execute or it does not execute. There is something called durability. Once a transaction is committed, the changes are permanent, even in the case of power failure or crash afterward, right? Even after that, suddenly if power fails or any crash happens or anything, once the transaction is committed, it is changed. Nothing could be, restored until unless you begin the transaction, right? So these are few, you could say, important things which you should keep in notice. We'll try to, gradually see few more things. For example, we have a customer table, like customer orders table, right? Always try to avoid functions, like if at all you can use it in where clauses, right? Avoid using functions on indexed columns in where clauses. So what are those indexed columns? We have seen that, and if at all you need to use those functions on indexed columns, better to avoid it. You can use like other conditions, right? Here you can see that it will lead to performance issues, right? As I have mentioned, and just like the query output would be the same. Suppose if I want 2023 orders, I have these orders, right? I have these orders. The same query I could write with uncondition also, right? The same orders I could get. So this is one more thing. Next thing is how to handle nulls. Okay, so you need to be mindful of null values. If you don't consider null values, then it could result in wrong values, or else the inappropriate representation of data. Okay, suppose you want to find out where the order amount column is null. Instead of writing equal to null, you'll use something called is null. Okay, is null, you'll use it in order to fetch that rows which has the null values. You can see 13 and 15 row, it has null values in this order amount column, right? We'll understand few more things. You can use coalesce function in order to replace null values. For example, we can use coalesce. If order amount is 0, sorry, if order amount has null value, I can use something called 0. If order status is null value, I can use something called as unknown, right? These are two different columns. You can use that aliases names. If I try to execute, you'll see this, right? Here we have order amount nulls, so I have zeros, right? Similarly, I have order status nulls, so I got something called unknown here, not here, here, unknown values here, right? In this way, you could understand how to use coalesce function. If something is null, instead of null, you can use this second parameter to give that replacement values, right? Hope it is understandable. And if at all we can use that is null function to replace similarly with coalesce, we can use those arguments, and it's useful in that, for creating the default values, right? Next is, I have shown you how to replace that order, right, with pending values. You can see this. If order state is null value, we can create even pending, right? So here you can see that null values, I just kept it pending. Next, if you could understand handling null value in order by classes, right? When it comes to order by class, here we are trying to fetch these four columns, right? When you are trying to fetch these four columns, what I'm trying to order by is, I'm trying to order by the order amount. In which format? You could say in by default it is in ascending order. Okay, now what it will do is it will try to order this order amount in ascending order, which means from low to high, right? Low to high. Next thing is, suppose when order amount is null, then what should happen? It will give that particular number 1, otherwise it will give 0. Right, based upon this, order amount will be ordered by. If you try to execute, you'll see the output and then you'll be able to understand. Here you can see this. My order amount is in low to high values, right? From starting from 75 till 500. In the bottom, you have that particular nulls, which is the next priority of this, right? That is what we have ordered based upon this order by class, depending on the case when statement, right? I hope it is understandable. You can use such like you can use such conditions, or you could say case when statements, in order to handle those null values. And when it comes to aggregation, you can put that is null function in the order amount, right? Suppose if the order amount has null value, you can consider it as 0. So 0 do not add anything to the sum, right? Whatever it is, the total aggregated value, it will show you that per appropriate 0, right? Here you can see that total is around 3333.75. I'll show you the even running total. We'll be seeing an example, but this is how you can handle that null values even in aggregation function, right? We can use something like exist operator, right? This exist operator, what it does, it will check that particular condition whether it is giving any output or not. If it gives any output, it will execute your select clause, right? So instead of using in operator, always try to use exist. How do we use in operator? You can see, rather than, if I execute this, right, you get all the customer orders, and you can get that particular customer orders. Those customer orders will be taken as the condition. But here what is happening? If at all this condition is met and if it gives any kind of output, we'll get that all the customer IDs available. Right? If I execute this, it will still give the same output, but it is executed based upon this particular subquery, right? Whether it, if at all it exists, then this particular select query will automatically run. Right? There is the difference, but exist is more efficient than this particular index, like in condition, or you could say in operator. So far, whatever we have discussed, is everyone able to follow? Next, we have to use like optimize the join order, right? We usually do different joins, but we have to make sure that whether the conditions which are made first, how whether it is impacting or not. Whenever you join with multiple tables, you make sure that you optimize based upon the based upon the appropriate tables in a proper order. Whenever it is possible, avoid unnecessary columns in group by. For example, here if you just run this query, here if you see this, I'm getting the order count of only 1 in all the rows. Reason is, even though if order date, is like order dates are different, right? So you'll be able to get only the group by values based upon both customer ID and order date. It will show only the 1 value, which is not appropriate, right? Rather than that, you can avoid the unnecessary column which is order date. If you avoid that, you'll get the respective customer ID and their respective orders, right? Similarly, whenever it is possible for certain complex conditions, you should try to use window functions, right? For example, if I just try to execute it, you can see this using window aggregation function based upon order by of order date and order ID. I'm able to calculate running total. What is running total? Each row it will keep on adding from top to bottom, right? If you see here both the columns, here in one particular row I didn't handle the nulls, other particular row I have tried to handle the nulls, right? So although it is giving the same value, but you need to make sure that you write the query appropriately so that the performance shouldn't get impacted, and also values, you should take care of those values. And if you see the output here, wherever those null values are there, you'll get the same output. If there is some value, the value will add on to the particular value and give the same output. At the end, you have the total output, which is 333.75, like 0.75. So in this way, you should try to use window aggregation functions wherever and whenever possible, right? Next best practice is try to avoid or condition in where clauses. For example, you have a query like this, right? Suppose either either the order status is shipped or order status is delivered. If you want both the kinds of data, like you can see, you're able to get this shipped values, right? Instead of that, if at all you use that union, it is a good practice, right? Although it gives us the same output, it is better to use that union, right? Let me see that particular status so that I can change those particular values. Okay, so it is either shipped or completed or pending, right? So instead of delivered, what I'll do is I'll just change it to completed, right? So here I'll change it to completed. Now if I try to execute both the queries, you can see here we have got 8 rows, and here we have got 9 rows, and here also we have got 9 rows. Output will be the same, but the performance, it is good to use union instead of or condition, right? Or condition in where clause, it will lead to poor performance. Next thing is when you use some set based operations, so do not try to use in like cursors. Instead of that, you can just try to use that normal conditions or and update the data, right? Cursor sometimes can be slow and inefficient. Instead, you can use that set based operations for better performance, right? So you can just try to use union all, intersect, except, all those things rather than using cursors to fetch that relevant data, right? Avoid using cursor. So cursor is a like typical topic where you could understand, it will take some time for you to understand. So but you could understand that instead of cursors, try to use set based operations. So these are few good practices, and there are four more important points for you to understand. Okay, so here you could understand, use database specific features. For example, we have some specific features like window functions, like partitioning in PostgreSQL, window functions in SQL Server to optimize performance, right? And also maintain it. And also for the maintainability, you should try to prefer all, like you should try to use those functions more widely. Second thing is you need to archive old data, right? When you move old or rarely accessed data to separate tables in databases to improve performance of queries, the active data on active data, so it will help you to fetch it fastly. For example, suppose you have 20 years of, right? Suppose you have 20 years of data, and mostly you will be querying maybe within last 5 years of data, right? Last 5 years of data you fetch mostly. This past 15 years of data you can archive in another database and keep it separately so that your new database will help you to query all the results, and it will be more faster. That is what you could say archive old data, right? And also monitor the query performance. You could understand that I have shown you execution plan, right? In SQL Server, you can execute the plan, understand what are the slow performing queries, what is the kind of whether you have indexes or not, whether your queries are good enough to get the output quickly or not. You can use try to monitor those. Okay, in order to manage database connections efficiently, you can use something called connection pooling, right? You can try to explore about it to reuse some existing connections and reduce the overhead of establishing new ones. So if you keep on creating more and more connections, so it will become a pool, and it will try to reduce the efficiency. So it is always good to use only limited database connections so that you can use it efficiently, right? And the last point to be understood for this session, you could understand avoid over normalization. Why do we not do the normalization? To reduce that data redundancy which are present in large tables, right? We create multiple chunk of tables from the large table to maintain that data redundancy, or you could say avoid, like we have to normalize the data. So when it comes to complex queries, and when it comes to performance, do not try to over normalize. Again, we should maintain a balance between the normalization as well as performance, and also with respect to the queries, right? You need to understand what are the number of dimensions you have, whether like creating the dimension tables, would it benefit or not. You have to check by writing queries, right? So these are few important best practices which you could follow while writing SQL queries, right? So I hope it is understandable, and